Okay, good afternoon again. Our today's main topic is chapter 2, vectors. It's very important for basic and necessary topics. 2.1, what's a vector? A vector is a mathematical object possessing and fully described a magnitude and direction. It's possible to talk about vectors simply in terms of numbers, but it's often a lot easier to represent them graphically as arrows. The vector's magnitude is equal to the length of the arrow, and the direction corresponds to where the arrow is pointing. Physicists commonly refer to the point of the vector as its tip and the base as its tail. Vectors are written in boldface and vectors magnitude in plain script. For example, vector A has a magnitude of A. The bold letter is vector and the magnitude is not bold. 2.2, vectors versus scalars. In contrast to vector quantity, a scalar quantity doesn't have a direction. It's fully described by just a magnitude. Example of a scalar quantity includes the number of the words in this sentence and the mass of the Hubble Space Telescope. Vector quantities you likely come across quite frequently in physics include displacement S, velocity V, acceleration A, force F, momentum P, electric field E, and magnetic field B. When doubt, ask yourself if a certain quantity comes with a direction. If it does, it's a vector. If it doesn't, it's a scalar. Now I want to go to vector subtraction. You probably know that subtraction is the same thing as addition, adding a negative. 8 minus v is the same thing as 8 plus negative 5. The easiest way to think about vector subtraction is in terms of adding a negative vectors. What's a negative vector? It is the same vector as its positive counterpart, only pointing in the opposite direction. You can see the figure. A minus b then is the same thing as a plus minus b. For instance, let's take the two vectors a and b and show as the figure. To subtract b from a, take vector of the same magnitude as b but pointing in the opposite direction and add the vector to a using either the tip to tail method or the parallelogram method, as you can see from the figure. We'll see next time multiplication by a scalar. It's very important topic. Don't forget to subscribe. Have a nice time.